Part 2 of your homework tonight is all of the values around the unit circle, the sine, cosine, and tangent values that you guys are going to need to know. If you can create a chart somewhat like this in your notes for 0, 30, 45, 60, and 90, those are all your special angles that you guys are going to have to memorize. But not only in the first quadrant, we're going to have to talk about the second quadrant, third quadrant, fourth quadrant, and all the way around. So when you guys are looking at the unit circle that we're going to look at in just a moment, remember, first quadrant here, your y and your x. X and y are both positive. Remember over here in quadrant 2, your x is now negative, but your y is still positive. Okay? Quadrant 3, you guys have both values negative. X is negative and y is negative. And in quadrant 4, your x is positive, but your y is negative. So this goes directly along with your sine, cosine values and your tangent values. In the first quadrant, sine, cosine, they're both positive. So that means if tangent is equal to your sine divided by your cosine, well, positive divided by positive would mean that cosine is, or tangent is also positive in the first quadrant. When you guys look at the second quadrant, with x being negative and y being positive, cosine's negative, sine is positive. Well, positive divided by a negative makes tangent negative here. Down in the third quadrant, if cosine's negative, sine is negative, they're both negative. So negative divided by negative makes tangent positive in the third quadrant. And then in the fourth quadrant, with x being positive and cosine being negative, negative divided by positive, again, tangent's negative. So tangent is negative in 2 and 4, and positive in 1 and 3. If we take a look back at your unit circle, your special angles, you guys are going to need to know all the way around your circle. So if I go to 30 degrees, or pi, which is 180 degrees, divided by 6, that would give us 30. So pi divided by 6 gives us 30 degrees. 30 is our degree, pi over 6 is our radian measure. That means that when you guys are looking at your sine and cosine value here, notice how sine is going to get bigger as you pull around the circle. This y value gets larger, which makes sense why at 90 degrees your sine value turns into 1, because this y value is stretching, and it continues to stretch until it reaches the radius, and the radius is 1 in our unit circle. Notice though that your cosine value got extremely small. So when you guys were pulling around the circle here, your cosine value, you actually saw it here, that x value you saw. Now, as you pull around to that 90-degree mark, it is getting smaller and smaller and smaller, which is why cosine goes to 0 when you guys are looking at a 90-degree measure. Now this does not just stop in the first quadrant. Let's pull around to 120 degrees. Your reference angle means, well, if I measure this angle, drop it down to the x-axis, this angle right here, if you notice, is still 60 degrees. It was the same 60 degrees that was in this first quadrant. The only difference is now when you measure it from 0, it's 120 degrees. But the reference angle is 60, which means that my sine and cosine value are still the same, except since we're in the second quadrant, my cosine has now turned into a negative. So if I look at 60 degrees in the first quadrant, you will notice that the sine and cosine values are the same value. However, one is negative, one is positive. So watch it as we go from 60 degrees, our reference angle of 60 degrees, reference again, meaning we drop that right angle down from the point on our circle to the x-axis, and we're measuring 60 degrees here. We're at 1/2 for cosine and square root of 3 over 2 for sine. Let's go over to 120. The same reference angle, since we're still dropping a perpendicular down to the x-axis. That reference angle is still 60 degrees. We're still looking at a cosine value of 1/2, but since we're in the second quadrant, we're now at negative 1/2. Square root of 3 over 2 is our sine value. Okay? This is going to continue. Remember, 45 was very similar in the first quadrant. Still have 45 as our reference angle, even though we are 135 degrees from 0. Well, notice here, my y value now is getting smaller. My x value is going to get bigger. If my y value continues to get smaller, what do you think is going to happen when I get down here to 180 degrees? Okay, so I'd like you guys to fill out your chart, but don't just stop at 30, 45, 60, and 90. Go ahead and continue your chart to 120, 135, 150, 180, and then 210, 225, 240, 270, 300, 315, 330, and 360. And write down your sine, cosine, and tangent values at all of those special angles in all 4 quadrants. These are what you guys should be able to picture, but you should also be able to draw that triangle, remembering from your notes that you guys drew your special angles in part 1 of the video. And if you have a 30-degree reference angle, remember what's across from it and whatever is adjacent to it. These are your sine and your cosine, and they're going to continue all the way around the circle. So go ahead and create your chart. My last 2 pieces that I want to leave you with for your notes tonight is think back now to, now that we've been talking about kind of your triangles that you're creating in a unit circle and you're starting to talk about radian measures a bit, think now about the length of an arc. And the length of an arc is a piece of the circumference. Oops, excuse me, there we go. That looks better. All right, piece of the circumference. So let's say I have an angle measured from the center of the circle, and I cut a piece of my circle out. What I want to know is, how do I find the length, this distance that goes around the outside of the circle, but I only want it for that section of the circle. I don't want it for the whole circle. So what you guys need to think back to is that circumference of a circle. Circumference is 2 pi r, or pi d. Okay, and you learned this back in like 7th grade, right? C equals 2 pi r. Well, that's for the entire circle. Think for a moment about what you would do if I just wanted a piece of the circle. So how many degrees are in a circle? You have 360 degrees in a circle. For an entire circle? Well, how would I break that down to 1 degree? And then how would I break it down to have like 30 degrees or 60 degrees? And then just find the circumference of that piece. So I'm going to leave you guys to think about that and do some work for tomorrow's class. The second piece is going to be the area of a sector. And you guys learned formulas for this last year. But I want you guys to think about why those formulas exist. Okay? Area of a sector goes back to, okay, well now if I close this in, and I want to find the actual area of whatever this piece is that I cut out, well, think back to it. It's just a chunk of a circle, right? So the area of a circle is pi r squared. If I'm looking at pi r squared and I'm saying, okay, well that's for the entire circle, right? And that's for 360 degrees. Well, how would I just chunk this one little section out? And my hint to you guys is to break it down into 1 degree. How would I do it just for 1? So think about that for class tomorrow.